Hello dear students, welcome back to the online classes. Today we are going to study the one more new topic known as inverse trigonometric functions. Dear students, in earlier classes already we have studied what is function. Let me brief about the functions. Let y is equal to f of x. If the relation y is directly expressed in terms of x is known as a function where x is called an independent variable and y is called dependent variable. And in last year's syllabus already we have studied the trigonometric functions. This year we are going to learn or we are going to study the inverse of these trigonometric functions. The weightage for this topic in this year's syllabus is one 1-mark question and one 2-mark question. The total weightage on this topic is 3 marks. Only 2 questions will be asked on this topic in the part A section for 1 mark and in a part B section for 2 marks. Therefore, the weightage is very small, but the questions are very sure in the examination which are expected for 3 marks. Now, my dear students, we are going to study how the inverse of the trigonometric functions exist. Before I start the existence of the inverse of the trigonometric functions, one should know the existence of the function is. If the function is both on1 and on2 or bijective, then only the inverse of the function exists. Now, generally, all trigonometric functions are not bijective. But if we restrict the domain of these functions and the range of the function becomes bijective. Hence, the inverse of the function exists. Now, here we take the first trigonometric function y is equal to sin x. If we restrict the domain of this function y equal to sin x to the closed interval minus pi by 2 and plus pi by 2 and to the range minus 1 plus 1, the function becomes bijective, that is both on1 and on2. Hence the inverse of the function exists and we denoted by sin to the power minus 1. That is, let y equal to sin x is a bijective function, then x will be equal to sin inverse of y is also a bijective. Therefore, the inverse of the sine function exists only if the domain of the function is in the closed interval minus pi by 2 to plus pi by 2 and minus 1 to plus 1. Likewise, we have the another function called as cos x. Y equal to cos x is a trigonometric function. Generally, as I told you, the inverse of the trigonometric functions does not exist. But if we restrict the domain of the function y equal to cos x to closed interval 0 to pi and range 2, minus 1 and plus 1, the function becomes bijective. Hence the inverse of the trigonometric function cosine function exists and we write or denoted by cos to the power minus 1. Let y equal to cos x is a bijective function, therefore x will be equal to cos inverse of y. Similarly, we have the few more trigonometric functions like tan x, cosec x, sec x and cot x. The inverse of these functions also does not exist. Once again, if we restrict the domain of these functions, then the inverse of these functions exist. The following table gives the inverse trigonometric function principal value branch along with their domain and ranges. Dear students, this table will help you to solve the 1-mark questions. Most of the time the 1-mark questions are given through this table. Now in this table, I have been given you the inverse function, inverse trigonometric function, its domain and its principal branch value. Now in the examination they may ask, if the sine inverse of the function is given to you, they may ask what is the domain of the sine inverse function is, or write the principal value branch or principal branch value of the inverse function is. Now let me take these functions one by one with respect to their domains and range. Let y equal to sine inverse, that is the first function. Under the domain closed interval -1 and +1, its principal branch value is minus pi by 2 to plus pi by 2. Likewise, we have the another function cos inverse of x. The domain of the cosine inverse of x is again closed interval -1 +1, and principal value branch of this inverse function is closed interval 0 to pi. Similarly, we have the third function known as tan inverse of x. The domain of the tan inverse of x is r minus of open interval -1 +1, and its principal value branch is minus pi by 2 to plus pi by 2 under the closed interval except 0. 0 is not included in the principal value of tan inverse of x. Likewise, we can take the another function cosec inverse of x, r minus of -1 +1, and the closed interval 0 to pi minus pi by 2. In this case, minus pi by 2, that is minus pi by 2 means pi by 2 is not included in the closed interval 0 to pi. Likewise, we have the next function sec inverse of x. The domain of this function is set of real numbers. We can denote it by the notation r or minus infinity comma plus infinity. And the principal branch value of this trigonometric function, inverse trigonometric function, is open interval minus pi by 2 to plus pi by 2. Last but not the least, the cot inverse of x is nothing but the domain of the function is set of real number and the range is open interval 0 comma pi. Under this principal value branch and the domain R, the inverse of the cot function exists and it becomes both 1 and 2. Now one important note here, my dear students. The value of an inverse trigonometric functions which lies in the range of the principal branch is called the principal value of inverse trigonometric function. Dear students, the value of inverse trigonometric functions which has or which lies in the range of the principal branch is called the principal value of inverse trigonometric functions. This is an important note. This value will be called as the principal value branch of the respective or the corresponding inverse trigonometric functions. Therefore, my dear students, this table will help you to get the 1 mark question. Now, my dear students, we will solve the few more questions with the help of the trigonometric functions of standard angles and the domain and range of the inverse functions. Exercise 2.1, question number 1. Find the principal value of sine inverse of 1 by 2. Actually, here it is given sine inverse of -1 by 2. Dear students, there are the total 9 properties in inverse trigonometric functions. One of the 9 properties is nothing but sine inverse of -1 or minus x is always equal to minus sine inverse of x. With the help of this property and by standard angle table, we are supposed to find the principal value branch of sine inverse of -1 by 2. Look at this example or how to find the solution of this problem is. Find the principal value of sine inverse of -1 by 2. Let me consider sine inverse of -1 by 2 is equal to y. Then sin y is equal to -1 by 2. As we know that sine inverse of -1 by 2 is always equal to minus of sine inverse of 1 by 2. And we know that minus sign as it is, sine of which angle is 1 by 2, which is nothing but a 30 degree. Therefore, we can write it as a pi by 6. Therefore, sine inverse of minus 1 by 2 is always equal to minus pi by 6. And this value lies in the range of sine inverse closed interval minus pi by 2 plus pi by 2. Therefore, minus pi by 6 is known as the principal value of sine inverse of minus 1 by 2. Now, moving to the next question, second problem. Find the principal value of cos inverse of root 3 by 2. This is a very easy sum or important sum. You can say cos inverse of root 3 by 2. There is a no negative sign. Therefore, we can write directly answer by or at the help of standard angle table. Now, cos of which angle gives root 3 by 2? As per the standard trigonometric functions of standard angle, we know that the cos of 30 degree gives root 3 by 2. Therefore, cos inverse of root 3 by 2 gives what it is? Pi by 6. And this value lies in the closed interval 0 to pi. Therefore, such value will be called as principal branch value of the given inverse trigonometric function. Look at the given problem. Here we have the given function cos inverse of root 3 by 2. Cos inverse of root 3 by 2. The cos of which angle gives pi by root 3 by 2 is? It is pi by 6. Therefore, the pi by 6 itself is the principal value branch of the given inverse function. Moving to the next question. Find the principal value branch of cosec inverse of 2. Now, this is also a simple example to find the solution of this problem is. Now we know that cosec of which angle gives cosec of which angle gives 2? The cosec of 30 degree gives pi by 6. That is 30 degree gives 2. Therefore, cosec inverse of 2 will be a pi by 6. Therefore, this value which lies between minus pi by 2 and plus pi by 2 excluding 0. Therefore, the pi by 6 is called the principal value of given inverse trigonometric function. Dear students, moving to the next question. As we know that sine inverse of minus x is equal to minus sine inverse of x. Likewise, tan inverse of minus x is always equal to minus tan inverse of x. Therefore, with the help of this property, we can find the solution of this problem. As we have been given that tan inverse of minus root 3 is always equal to minus tan inverse of root 3. But we know that the tan inverse of which angle gives root 3? That is nothing but 60 degree. Therefore, the negative sign remains as it is, and 60 degree is nothing but pi by 3. Therefore, tan of which angle gives minus root 3? The tan of minus pi by 3 gives tan inverse of minus root 3. Therefore, the minus pi by 3 is the principal value branch of the given inverse trigonometric functions. With this, we have solved the examples based on the first two properties, sine inverse of minus x and tan inverse of minus x. I hope, my dear students, you have understood the today's class. If you have any queries, please contact the given below number. Thank you. Stay home, stay safe.